We will now discuss the conditions under which an object will remain in a state of equilibrium under the action of several forces. Now, this object is in a state of equilibrium. This mass is in a state of equilibrium under the action of two forces. What are they? The weight of the object is acting vertically down, and the normal force applied by this marker is acting vertically down. We say the sum of the forces acting on this object is 0, keeping this in a state of equilibrium. Now, is it possible that I can keep this ruler in a state of equilibrium on here? You can see it's, well, it was almost in a state of equilibrium before it slipped off. Is that right? Well, I can, with some perseverance, yes, this is in a state of equilibrium. What are the forces acting on this ruler now? You can see, once it is in equilibrium, I can move it around. What are the forces acting on the ruler when it is in equilibrium? The weight acting downward and the normal force acting upward. That makes the sum of the forces acting on the object 0. Now, what are the forces that will keep this in equilibrium? Now, watch this. I'm holding this mass by means of this string. Now, I want you to discuss the conditions under which this point is in equilibrium. What are the forces at that point? There are 3 forces at that point. Can you tell me what those forces are? One is the tension on the string on my right hand, the tension of the string on my left hand, and the third force is the weight of this mass. And all those 3 forces are acting at this point. Now, that point is in a state of equilibrium. Why? Because the forces are balanced. So, an object may remain in a state of translational equilibrium. In other words, it doesn't move in the X, Y, or Z directions. Translational equilibrium, if the sum of all the forces in the X direction is 0, the sum of all the forces in the Y direction is 0, and the sum of all the forces in the Z direction is 0. Well, tell me, will an object to remain in equilibrium if the sum of all the forces acting on it is 0? Well, now look at this rod. I'm going to apply a force upward on my left. Well, on my left will look like your right. So I'm going to apply a force upward here and downward at the other end. The equal forces. I'm going to apply equal forces, one upward and the other downward. Well, the sum of the forces is 0, but is this in equilibrium? Let's see. Look at that. I'm applying a force downward here and upward on the other end. Is this in equilibrium? And I change the direction of the force. Is this in equilibrium? No. Therefore, what is the condition that you need to be satisfied in this case? Well, the force I apply on the right side upward produces a torque. Is that right? It produces a torque. What is the direction of that torque? You see, that torque is rotating this rod in the counterclockwise direction. It is a counterclockwise torque. And the force that I apply downward here is also producing a counterclockwise torque. That means these two torques will add up to give you a net torque. If this has to remain in equilibrium, the net torque has to be 0. So, before we write these things down, let's talk about this one more time. When you talk about equilibrium of an object, the objects may remain in a state of equilibrium with respect to translational motion, also with respect to rotational motion. In order that an object may remain in a state of equilibrium, the object should not be having any translational motion. That means the sum of the forces acting on the object must be 0. Also, the object should not have a rotational motion. That means the sum of the torques of all the forces acting on the object taken about any point must be 0. Now, before we go on, let me see if I can draw that situation for you. If I have this is the object I have, a force, say F1, acting on this can produce a rotation on this object about this point A. The force is acting at the point B. Now, what is the torque of F1 about point A? Now, when I say the torque of F1 about point A, what I actually mean is the torque of the force F1 about an axis that passes through A. Now remember, rotation always happens about an axis. Is that right? So we want to find the torque of this force F1 about an axis that passes through A. What is the torque of a force about an axis? It is the force multiplied by the perpendicular distance between the force and the point. Therefore, this torque is the distance AB, that is the torque arm, multiplied by the force F1. Now tell me, what is the direction of this torque? A torque can produce a clockwise rotation or a counterclockwise rotation. I'm sure you can now distinguish between these two. Tell me, what kind of a rotation is this F1 producing about this point A? Watch my right hand. Well, my right hand will look like my left hand for you. Now, I'm going to point at A. That is my fulcrum. That is where the axis of rotation is. Now, look at the way F1 is going to rotate. The F1 is going to produce a rotation in that direction. What kind of a direction is this? This is counterclockwise. Counterclockwise. Alright, so we say the force this force F1 produces a counterclockwise torque about the point A. Well, suppose I have a force F2 at the point A. Tell me, what is the torque F2 can produce about the point B? When I say about the point B, I mean about an axis that passes through B. What is the torque of? Let me see if I can write it with this. What is the torque of F2? Torque of F2 about the point B. The torque of F2 about an axis that passes through B, it will be the torque arm AB multiplied by the force F2. AB multiplied by the force F2. Now tell me, what kind of a torque is this? If I now hold my finger at B, that is the axis, and rotate the rod using the force F2, look at the way the rotation is going to take place. The rotation is going to be like this. It is a clockwise rotation, isn't it? That is the direction of motion of the hand of a clock. That means the force F1 can produce a counterclockwise rotation about the point A, and force F2 can produce a clockwise rotation about the point B. That means these two torques oppose each other. So, if one is positive, the other will be negative. We can choose which torque you want to call positive and which you want to call negative. Now, for convenience, we're going to call the counterclockwise torque as positive and the clockwise torque as negative. So, when you want to write the torque of force F1 about point A, it is a counterclockwise torque. Therefore, it will be positive. If I don't put a sign there, it means it is positive. Whereas the torque of F2 about point B will be a clockwise torque, and that will be negative. So I will now use a negative sign. Tell me, what is the sum of the torques due to these two forces? What is the sum of the torque? In other words, what is summation of tau? Is add these two torques. And if the forces are of equal magnitude, this sum will be 0. Now, if the sum of the torques equal to 0, that means the object will not rotate. So, now tell me, what are the conditions under which an object will remain in equilibrium? The conditions are the sum of all the forces acting on it must be 0, and the sum of all the torques of all the forces. Now watch the sentence. The sum of the torques produced by all the forces taken about any point must be 0. Alright, let me try to explain. I have represented a beam here. There are forces, I have marked points A, B, C and D. And there are forces F1, F2 and F3 acting at points B, C and D. If this object has to remain in equilibrium, it means the sum of the forces must be equal to 0. Now, if an upward force is positive, a downward force is negative. So I can then write F1 plus F3 minus F2 equal to 0. Now, this tells me that the sum of all the y forces equal to 0, forces in the y direction, summation Fy equal to 0 gives me F1 plus F3 minus F2 equal to 0. Well, that alone will not keep this object in equilibrium. What is the other condition that we need to satisfy? We need to add the torques produced by all these forces taken about any axis, because the object cannot rotate about any axis. Now here I can take an axis that passes through A, I can take an axis that passes through B, I can have an axis that passes through C, I can have an axis that passes through D. The object should not rotate about any of the axes. That means if you take the torques of all these forces about any axis, the sum of all those torques must be equal to 0. Now that means we can choose the axis of rotation. We can choose the axis about which the torques of these forces are going to be taken. Any point will be fine. If you choose any axis, the sum of the torques must be 0. Alright? Okay. Now tell me, what is the criteria for choosing the point? Let's see if you can answer this question. What is the torque of F1 about an axis that passes through this point B? What is the torque of, did you understand the question? What is the torque produced by this force F1 about an axis that passes through the point B? Remember, torque is the torque arm multiplied by the force. And the torque arm is the distance between, the perpendicular distance between the force and the axis of rotation. Now, you can see the axis passes through B, the force also passes through B. That means the torque arm there is 0. So, a very important situation. If a force passes through a point, then the torque of that force about an axis that passes through the same point is 0. It means the torque of F1 about B is 0. The torque of F2 about C is 0. And the torque of F3 about D is 0. Okay? So, we can now take the torque of all these forces about any point. Alright, tell me, what is the torque of F1 about an axis that passes through A? What is the torque of force F1 that passes through? What is the torque of F1 that about an axis that passes through B? Let's take it about B. What is the torque of F1 about an axis that passes through B? That torque will be 0. Why? Because the torque arm is 0. Alright, what is the torque of F2 about an axis that passes through B? Torque of F2 about an axis that passes through B, that will be the torque arm, the distance BC multiplied by the force F2. The torque arm multiplied by the force. Now tell me, is this a clockwise torque or a counterclockwise torque? Well, how do you know? What you need to do is, now use your index finger and point at the axis. My axis passes through B, there I'm pointing. And then draw a circle using the force around that axis. F2, the torque of F2 about the point B. Look at this. What kind of a torque is it? It produces a torque in the clockwise direction. So this is a clockwise torque, therefore it is negative. Isn't that fair to call that torque negative? It is a negative torque because it is a clockwise torque. Alright, now tell me, what is the torque of F3 about an axis that passes through B? Torque of torque of F3 about an axis that passes through B will be the torque arm, that is the distance BD. So that will be the distance BD multiplied by the force F3. So the torque of the force F3 about an axis that passes through B will be the torque arm, the perpendicular distance between the force and the axis, that is BD, multiplied by the force F3. Now tell me, is this a clockwise torque or a counterclockwise torque? This is the axis of rotation about B, and F3 produces a counterclockwise torque, which means it is a positive torque. So this is a positive quantity. If I now ask you to add the torques, sum all the torques about the point B, what would that be? It will be, the sum of all the torques will be this BD times F3 minus BC times F2. Is that right? The torque produced by F3 is positive and the torque produced by F2 is negative. And when this beam is in equilibrium, that sum will be 0. And this is what we're going to use in solving problems in this lesson. Conditions of equilibrium of a rigid object. A rigid object will remain in equilibrium under the action of several forces, provided what? The sum of all the forces on it equal to 0, and the sum of the torques of all the forces taken about any axis should be equal to 0. This is what we're going to use in solving problems. Let's now review what we talked about so far. Well, we talked about equilibrium as a state of balance. Equilibrium is a state of balance. In order that an object may be in a state of equilibrium, all the forces acting on it must be balanced. That is the first condition. That means the net force on the object must be equal to 0. F net must be equal to 0. And I'm going to summarize this as the net force in the x direction must be 0. Summation Fx equal to 0. The net force in the y direction must be equal to 0. You see, this is a much more convenient way for us to use in solving problems. Summation Fx equal to 0 means if you add all the forces in the x direction, that sum must be 0. If you add all the forces in the y direction, that sum must be 0. And if you add all the forces in the z direction, that sum must be 0. Is that right? That is the meaning of the net force acting on the object must be 0. So, I just demonstrated to you that F net equal to 0 is not enough to keep an object in equilibrium. Why not? Because even when the net force is 0, there could be a net torque rotating the object. Now, when an object is in equilibrium, it has to be in translational equilibrium as well as rotational equilibrium. The object should not move, it should not rotate. So, consider two equal and opposite forces acting on this object. You got one force F acting down, the other force F acting up. These forces are balanced, is that right? Because upward force F minus the downward force summation of the y forces is equal to 0. The y force directed up is positive, a y force directed down is negative. The sum of the forces is 0, but the object is not in equilibrium. Why not? Because these two forces produce rotation on this object. Now, therefore, another necessary condition is that the sum of the torques of all the forces acting on the object taken about any point. The object should not rotate about any point. Summation tau net equal to 0 means the sum of all the torques, or the sum of the torques of all the forces taken about any axis must be 0. Summation tau equal to 0. So what are the conditions for equilibrium again? F net equal to 0, which can be written in three forms. Summation tau equal to 0. The sum of the torques of all the forces taken about any axis must be equal to 0. Alright, let's talk about the rotation for a while. Consider forces F1 and F2 acting at points A and B of an object. Now here's an object, that is point A, and this is point B. F1 is acting at point A, and force F2 is acting at point B. Now, point C, there is an axis, and we are now going to look at the rotation of this object about an axis that passes through C. That's the axis of rotation. The rotation produced by F1 about the axis passing through C is counterclockwise. Is that right? The force F1 produces a counterclockwise rotation like this. So force F1 produces a counterclockwise rotation about an axis that passes through C. We call this a counterclockwise torque. The rotation produced by F2, on the other hand, about an axis that passes through C will be clockwise, will be in the direction of motion of the hands of a clock. And we call this a clockwise torque. For convenience, we take the counterclockwise torque as positive and the clockwise torque as negative. Well, we could have chosen the other way around, but we can only choose one of them, so we will follow this pattern. All counterclockwise torques are positive and all clockwise torques are negative. Now, what is the torque of F1 about an axis that passes through C? The torque of the force F1 about an axis that passes through C will be the torque arm. Now, torque arm is CA multiplied by the force F1. CA times F1, and this is a counterclockwise torque, and therefore it is positive. Similarly, the torque of F2 about an axis that passes through C will be CB, the torque arm, multiplied by the force F2. It is a clockwise torque, therefore it is negative. I hope the concept is clear because we need to use it to solve problems. Summation of tau, what is the sum of the torques of these two forces about the axis that passes through C? It will be CA times F1 minus CB times F2. This is the sum of the torques. And in order that this object may remain in rotational equilibrium, the sum of the torques must be equal to 0. Let's now talk about another simple concept. What is a couple? A couple. Well, it is very often we use a couple in our daily life. Well, by definition, a couple is constituted by two things. And of course, in this lesson, we are talking about forces. So a couple is a pair of forces. Now, the important thing about this pair is that they are equal in magnitude and oppositely directed. Equal in magnitude and oppositely directed. I showed you an example of a couple actually a little while ago. I can produce a couple on this rod. Well, I can produce a couple on this. I can apply a force upward at this end and an equal downward force at the other end. Look at that. What does a couple do? A couple produces rotation about an axis. Now, how about the steering wheel of your car? What do you do to turn the steering wheel? You see that? Now what you're doing is you use a force downward and equal and opposite force upward so that these two forces act through different points. Now, a couple is constituted by two equal and opposite parallel forces so that their points of action are different. You see, only if their points of action are different will the couple produce rotation. If the points of applications are the same, a couple cannot produce rotation. Now, tell me, in this case that I demonstrated, one force upward and the other force downward, it produces rotation. Now, if I bring those forces closer and closer, is the rotation effect increasing or decreasing? You see, if I apply one force up and one force down very close to each other, the rotation effect is very small. And finally, if those two forces act to the same point, one force up and the other force down, will they produce any rotation on the object? No. So the rotation effect is maximum when the two forces are separated by a large distance. Now, a couple is constituted by two parallel and equal forces oppositely directed so that their points of applications are different. Can you think of some examples of couples that we use in our everyday life? Well, any example? Any example around that we use a couple? How about opening a water faucet? When you open a faucet, you are applying one force to the directed right, then the other force will be in the opposite direction. You are using a couple to open a water faucet. How about a screwdriver? If you want to drive down a screw, look at the force I'm applying. Now I'm applying one force directed that way on this side, another force directed in the opposite direction. I'm actually applying a couple when I want to drive a screw down. So we use couples, couple of forces in our everyday life. Now let's talk about the torque of a couple. What is the torque of a couple? So a couple is formed by two equal and opposite parallel forces on an object so that their points of actions are different. F1 and F2, here we have an object, a force F1 is acting at point A and a force F2 is acting at point B. They have equal magnitudes, means the length of the arrow are the same exactly, but they are oppositely directed. F1 equal to negative F2. Let's take a point C. We can now find the torque of these forces about an axis that passes through A. Let's take the torque of these forces about an axis that passes through A. Can you tell me, what is the torque of the force F1 that passes through what is the torque of the force F1 about an axis that passes through A? The torque of F1 about an axis that passes through A is 0 multiplied by F1. Why 0? The torque arm is 0 because the distance between the axis and the force is 0. Now, a very important concept. If a force passes through a point, the torque of that force about an axis that passes through the same point will be 0. The torque of F1 about an axis passing through A equal to 0. What is the torque of F2 about an axis that passes through A? The torque of F2 about an axis through A will be, the torque arm will be AB, and multiply that with F2. The torque arm multiplied by F2. Tell me, is this a clockwise torque or a counterclockwise torque? This is the axis of rotation where my pointer is. And see how my finger moves? F2 will rotate in the counterclockwise. So the torque produced by F2 about an axis that passes through A is a counterclockwise torque. Well, the torque of F2 about A is a counterclockwise torque. I did that one, but that is not what I wanted. Is that right? I wanted to represent this torque. The torque of F2 about A is a counterclockwise torque. That means, what is the sum of the torques about the point A? What is the sum of the torques of these two forces measured about an axis through A? The torque of F1 about A is 0. The torque of F2 about A is AB multiplied by F2. This is positive because it is counterclockwise. So the sum of the torques is 0 plus AB multiplied by F2, which is AB multiplied by F2. All right. We now take the torque of these two forces about the point B. What is the torque of F1 about the point B? The torque of F1 about the point B is the torque arm BA multiplied by the force F1, and that is a counterclockwise, isn't it? It is a counterclockwise torque. It is positive. Well, I got them the other way around. Okay, the torque of F1 about B is a counterclockwise torque. How about the torque of F2 about B? The torque of F2, now this is F2, it got covered by my arrow. This is F2, and this is the point B. What is the torque of this F2 about that point B? F2 passes through B, therefore the torque arm is 0, and that torque therefore is 0. What is the sum of the torques of these two forces about B? That will be BA times F1. But isn't BA times F1 the same as AB times F1? Because BA and AB are the same length. You see that? So the torque of these two forces, whether you take it about point A or whether you take it about the point B, it will be always equal to the torque arm, the distance between the forces multiplied by one of the forces. Now remember, this F1 is the same as F2 in magnitude. So if you want to find the torque of a couple, what all you need to do is multiply the perpendicular distance between the forces by one of the forces, and that will be a measure of the torque of the couple. So I have defined it here. Torque of a couple is the product of one of the forces and the perpendicular distance between the forces. A couple like this, the torque of a couple is the product of one of the forces and the perpendicular distance between the two forces. Alright, now I'm going to stop this part of the lesson here. We will use these concepts that we developed in solving problems in the next part of the lesson. Alright, I will see you for that in a minute.